All right, looking at this probability expression as a binomial probability, this would be the probability x is less than 25. That does not include the 25. So if we were using the binomial distribution, in particular the binomial CDF on your calculator, we would be finding the probability x is less than or equal to 24. However, under most conditions, the binomial distribution can be approximated by the normal distribution. However, the binomial distribution is a discrete probability distribution, and the normal distribution is a continuous probability distribution. So we need to account for that. So this expression here is the probability x is less than 25. So applying the continuity correction here, since it does not include the 25, this would be the probability x is less than or equal to 24.5. Okay, so visually, what that means is I'm assuming that this binomial distribution can be approximated by the normal distribution, so I'm just going to draw a generic bell curve. So the number 25 in the continuous case actually is represented by adding 0.5 above and subtracting 0.5 below. So the number 25 is this area here in the continuous case. So going back up here, if I'm not including the 25, then I need to stop at 24.5. Okay? So let's go ahead and do some conversions between discrete and continuous, and hopefully this will help you with your homework. Okay, so I'm going to use the number 25 for x in this situation. All right, so if x is equal to 25, okay, the case of equality, right, so this is equal. What that means is I want to find the area in the continuous case between 24.5 and 25.5. So in the continuous case, that can be represented as this inequality. 24.5 is less than or equal to x is less than or equal to 25.5. All right, so if x is greater than 25, all right, that would be greater than. Sorry, I'm writing a little small here. Greater than. That does not include the 25, so looking back at our sketch, that would be the area that goes from 25.5 to positive infinity. So as expressed in inequality notation, this would be the probability. Actually, I'm not going to use probability. I'll just keep it as inequality. Okay, the corresponding inequality would be x is greater than or equal to 25.5. Now, for the case where x is greater than or equal to 25, okay, now we have the case of equality. So this is greater than or equal to. We are now including the number 25. Now remember, 25 in the continuous case goes from 24.5 up to 25.5. So if we want to be greater than 25, greater than or equal to 25, we would need to go down from 24.5 up to positive infinity. So in the continuous case, that would be x is greater than or equal to 24.5. Now, for x less than 25, okay, so we've got less than. Again, that does not include the case of equality, and that's the one I started with up here. Okay, if I'm not including the number 25, and remember 25 in the continuous case goes from 24.5 up to 25.5. If we're not including 25, then we would be looking at everything below 24.5. Okay, so that's x less than 24.5. All right, and then last but not least, we could have x less than or equal to 25. Okay, so that would be less than or equal to, okay, less than or equal to 25. Now we're including the case of equality. So we want to include the whole number 25, but in the continuous case, 25 goes all the way up to 25.5. So in the continuous case, as in an inequality, that would be expressed as x is less than or equal to 25.5. Okay, so this is the first step of these probability problems, and in the next video we will do a whole problem where we first convert using the continuity correction factor, then find the corresponding mean and standard deviation, and then find the probability using the normal distribution.